The talk is about why is we can still say this MLE, which is multilinear extension, also as a Lagrange interpolation. Yeah. I think it's a topic so simple that no one had talked about yet. Maybe at least explicitly. It's just a primary school math, right? So I mean, this one is for the univariate polynomial. Which kind of like we have k points, like x0, y0 to xk, yk, and we interpolating these points as a as a polynomial, which can be written as something like I0 to k and y by some Lagrange polynomial. And this is a Lagrange polynomial and also the basis of this space, polynomial space, which can be written explicitly as something like what does it like maybe pi I say the thing about the symbols, but maybe j is equals to 1 to this k. It's just like some x. But the j cannot be equals to I, right? When this is I. So the x minus x.
Excuse me. Yeah, it's kind of hard to see from here. Can you write it like this, please? Yeah, that'd be great. Thank you. Okay. Or the other way, or maybe there.
Yeah.
Sorry, it's just kind of one thing.
I just
Thank you.
yeah, swing like this. Okay. So yeah, will write the denominator. It's just xi minus xj, right? So, and that's the Lagrange interpolation for the univariate polynomial. And the multilinear extension, like we write it in some textbook, like the adjusting saver ones. It's like so the MLE is just to extend some polynomial. It's from it's just f, but this f is just original from some Boolean hypercube. M-dimensional Boolean hypercube to some finite field. And we extend this to some multilinear polynomial f height, which I think is from some Baker space m, like m to the f to the m to f, right? So the formula of this MLE is like what? thing in the textbook. Maybe we can, let me think about it. Maybe I can check. But it's like also something like that thing. Like, just over, we introduce some index way, which is the vertex that just traverses there's one hypercube, and the value of the way times something called equality function EQ, which will take this way and x as the argument, and this EQ Vx is like what? It's defined as something like this pi, and we'll use I goes to 1 to pi, and x xi vi plus 1 minus xi 1 minus vi, right? So like you can say if the x is just equal to y,
Kurt, just
It's fine.
please.
it's okay.
That's clear.
So
It's red.
Yeah, I mean we cannot see that.
Blocked by our back.
Your body is just standing in front of that. We cannot see.
oh, okay, I see. you stay here also.
Yeah, I mean,
So-
maybe after you read that, you can explain again. So we'll know that while you read.
But yeah, like the what I want to say is if only if the x is equal to equal and this equal function is equal to 1 comes true, right? If x is not equal to y, this function should be 0. If the just one dimension of this is not equal, and there should be some zeros here, so the whole equal function here should be 0. Only if the y is just equal to x, and this equal function is equal to 1, so the point is it's equal to f way. Yeah. But how does this one and this one related? I think
There was selector problem. Selector.
since the basis, right? It's the basis of the space both. But only if you see the connection of these two bases, you can say the claim that this is also the multilinear version of the Lagrange integration, right? So we just need to write this one take this one into something like this one, right? So how to interpret it? It's a simple trick is that we can say this as something like we can write this in the as something
into a conditional function. Right. It's just like a function. It's equals to xi if vi is equals to 0, right? And which will be evaluated into 1 minus xi if vi I think this one should be 1, right? It's just a selector. Yeah. If vi is equals to 0. Right. It can be written to this conditional function. And so based on this, we can to write the equal function as something like this. We divide it into these two parts. The first part is all of the I which for which vi is equals to 1, right? And this one should be xi. And the second part is that all of the I when vi is equal to 0, and which will be 1 minus xi. And we just write this as something like this, which is xi minus 0, right? And the denominator, we can add 1 minus 0 here, right? It's just 1. Well, why is that? I will explain. The similar is just in here. 1 minus xi divided by something like also 1 minus 0. So what does this 1 minus 0 means? I think it's just the volume of the hypercube, right? So the volume of the 0, 1, 2 is just 1 minus 1 squared, right? We can, so these two things will form the volume of the space which is a hypercube here, which is integrated on. So
what do you mean volume?
Volume is like the area of this one. If this is AB, so the area of this AB. So in the three-dimensional, the volume is just
capacity.
TG.
Volume capacity.
Oh,
It's just like in here is the volume of the Boolean hypercube is just 1. So we usually in the original form we didn't mention it, but like this you can see some similar structure with the original one, right? Because you say when the vi is I and you just so this y is corresponding to something like the L0 x here, there. And when y is equals to 1 and the 1 here is something like the other point, which is L1 there. So it's just a two multiplication of the Lagrange basis, right? And yeah, is that clear? I think it's that.
but maybe there should be some more general formula form here. Yeah. But that's a simple trick. So that's all. Thank you.